So we talked previously about aquatic plants, and we're swinging all the way over to the other extreme of plant-water relations. And water in these environments is on the dry side. Water is scarce. So these are plants that are called xerophytes, and I don't know if everybody calls them that, but this is based on Greek roots for a word you might encounter, xeric, and that just means dry. So we do have desert parts of the world. Nice illustration of one here. These are areas that get very little precipitation. They could be warm, they could be cold, but they are definitely dry on average, a lot drier than other parts of the world. And so the plants that grow in these places, we call them xerophytes. They have special adaptations to grow there. And as we'll see in a lot of these ecological contexts, this is a group of plants that certain plant families are more represented in these kinds of environments. So as you might imagine, lots of adaptations necessary to thrive in this kind of environment. Still an abundance of plants, but ones that need to have the right tools to be there. So just to revisit what plants need, we looked at this in the context of water plants. Aquatic plants have an abundance of water, but they might have some challenges with gas exchange, with sunlight, depending on where they're located in the water. Plants in the desert, not so much trouble getting sunlight. So this is an environment typically doesn't have a lot of shading, not a lot of trees of any appreciable size that really would be able to shade out plants. So they do all right for sun exposure. And in fact, they're probably experiencing too much sun exposure. So we might have some adaptations that actually prevent plants from getting too much sun. Sun enables photosynthesis, but of course, sun also will increase heat, evaporation, and solar radiation can cause damage to tissues as well. So lots of sunlight, but maybe too much sunlight. Not a lot of water. Water is sometimes just overall scarce. A lot of desert environments have periodic rain. So in the southwest of the United States, they actually have a monsoon season where it rains a whole bunch, but that's only at a little bit of the year. And for most of the year, this is a dry environment. Nutrients, I think this is worth mentioning. These habitats typically don't have a very rich organic layer in their soil, not a lot of organic material, not very fast growth, and so not a lot of decomposition to bring those nutrients back into the soil. There's not a lot of plants or animals in the environment, and not a lot of turnover on an organic level. So it actually is a little bit limiting to get the right kind of nutrients. Sometimes there are like mineral toxins in these environments. Sandy soils can be problematic from that perspective. So maybe other considerations besides just the water issue in the desert environment. So when we talk about xeric plants, we can look at parts of the world that are more enriched for desert plants. As I mentioned, deserts are areas that get low precipitation. And the precipitation of an area is typically a factor of the movement of the air around them and how these weather systems move through an area. A lot of times they're influenced by mountains. So for example, in the United States, we have the Rocky Mountains, quite a large mountain range here, as well as the Cascade Mountain Range on the West Coast. And those affect the ability of precipitation to drop in these areas. So we get kind of a rain shadow in these environments where it's drier, typically not as much rain in these environments. Other parts of the world would have similar impacts of basically where the rain falls or does not fall. And you can probably picture a lot of these have names for the deserts that are located there. So Sahara Desert, the Arabian Peninsula, the Namib Desert in Southwest Africa, Gobi Desert in Eastern Eurasia, and so on. Some larger than others. And as we saw this from space, this was an area that didn't have a lot of plant density. So these are areas that don't light up very green on the global satellite map. But nonetheless, there will be some plants there, often just not a very rich abundance of plants. So how do you become a plant that grows in a dry environment? There's some general strategies. Again, there's a lot of diversity of plants that can grow in the desert, and they don't all have the same strategies. So there are different ways to be successful. Basically a matter of conserving moisture, and not falling victim to any of the other environmental pressures. So I want to kind of highlight some of the reasons that I've chosen these photographs for this image as we go through. So adaptations to obtain water, and sometimes that's maybe a little bit different than you might think. So I mentioned these areas that sometimes have monsoon rains or infrequent rains, and when the rain happens, it drops a lot of water. And so the adaptation that's necessary for that kind of water availability is to grab what you can in a short amount of time. And I chose this image, I like this as a concept. If you think about it, this is a cactus on its side. And this cactus, you can see its root system, not very deep. So I think often you might imagine that in a desert, if you could only manage to grow your roots deeper, you would access water. Sometimes that's true, sometimes not so much. And this plant has a strategy to grab the water from near the surface when the water falls from the clouds. So it's got kind of an extensive shallow root system and the ability to transport that into the storage tissues when the water is available. So that brings us to our next point. Water storage is a pretty common adaptation. You often see swollen organs. So in this cactus here, we've got swollen stems. In the aloe that's being shown here, these are succulent leaves that are thick with this slimy mucilage that's holding on to lots of water. This is a reason people like aloe as a source of, I guess, moisturizing. Other plants here, we've got a storage structure at the base of this plant, kind of at the base below where the branching out happens with the leaves. So water storage, pretty common. I think that's a common thread for all the plants that are imaged on here. Preventing water loss. So once you've got that water, being able to store it, as in devoting some tissues, a massive amount of tissue for storing that water, like a space to hold it, but also the ability to stop from losing it. So where plants are usually losing their water, terrestrial plants often lose water through their pores, the stomata on their leaves. And so desert plants typically don't have so much in the way of stomata or even leaves for that matter. A lot of times they've lost their leaves. If they do have an epidermis that's exposed to the surface, it's often very waxy or thick. And so this thickness and waxiness that can help hold on to moisture. They're very cautious, these desert plants, about how much water they let out. As we'll see, there's a bit of a trade-off with being able to breathe, which plants do need to do, and also losing their water. So they have to kind of take a concerned approach about that. Preventing water loss here, just abiotic, basically preventing water from going out of your tissues because it's hot and because it's dry outside. But other things can also take your water. For example, if you are a wet, juicy plant in the desert, that is a prime target for an animal. So an animal might desire to chew on these desert plants, and adaptations arise to prevent that from happening. So plants that are defended, we see a lot of spines and other prickly bits on plants. This is the leaf margin with some very extreme teeth on it. This prevents animals from really wanting to go at eating these plants. They're well defended, and so they hold on to their moisture. Animals would love to get their moisture, but they have a hard time doing that. This is a plant called living stones or lithops. This one actually kind of camouflages itself like rocks. So when it's not flowering, this is a pair of leaves across from each other. They don't look much different from a rock right there. So a good way to prevent losing your moisture is to prevent being found. Another example here of a prickly plant. Also, one that's a little bit difficult to illustrate, having toxins. We see a lot of toxic plants in the desert environment. So this can be a toxin to an animal that prevents them from wanting to chew on these juicy structures as well. So lots of common adaptations. Any one of these plants that we'll talk about might have one or a few of these adaptations. Another strategy that's kind of outside of that set of strategies we were just looking at is a strategy called being a desert annual. So we talked about annuals. In Wisconsin, we often think about annuals as being a winter annual. So as winter comes on, the conditions around here become freezing, they become dry, and that's prohibitive for a lot of plants to grow. And the annual strategy, the annual growth strategy, is to, rather than put effort, as in tissues, devote adaptations to keeping yourself alive in the winter, annual plants just give up on their plant body and instead rely on seeds to keep them going through the winter. And you can see that same strategy in some desert plants, these desert annuals. they have a life cycle where they do also just die completely, except for the seeds that they've left behind. And so we get one of these interesting features that sometimes comes up, massive bloom of plants. So in these rare events where rain actually hits an environment like this, you can get these short-lived but spectacular shows of flowers. Just, you can see from the color here, these are just flowers of the same species over and over and over again, filling the landscape here in this really dry area of the world, the Atacama Desert, following a brief rainy period in 2015. So you don't have to be adapted to hold on to moisture if you are otherwise adapted to do your reproduction really quickly. All right, so one of the terms we're going to use in the context of xerophytes is to call them succulent. Succulent is just kind of a fancy way of saying juicy. So these are plants that hold on to moisture, and you can kind of characterize them by these structures that are devoted to holding on to moisture. So they've got enlarged, squishy tissues, maybe more or less squishy, sometimes rather firm, modified thick stems in a couple of these. These are stem succulents in a couple of families, Cactaceae, Euphorbiaceae, and then quite a few leaf succulents. So a little bit difference, and then I'm going to focus on this difference in what organs are more modified for storing water. So stem succulents, and we'll get into those first.